Hi guys, Miss Scott here. So we're going to jump right into chapter 2 starting with section 2.1, using inductive reasoning. And before we get into actually the formal definition of inductive reasoning, we're just going to look at some patterns. So I encourage you to use this example here to try these first 3 examples and pause the video, give them a shot. We're going to jump in though, so if you finished those, great. If you just want to work with me, that's fine too. In example 1 through 3, we're going to sketch the next 2 figures in this sequence. So in example 1, I noticed that each side here has 2 dots. And then the next picture, each side has 3 dots. The next one, each side has 4 dots. So in the next picture, each side is going to have 5 dots. So we're going to make a triangle with 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's got 5 dots on each side, and then the next picture would have 6 dots on each side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. All right. Let's look at example 2. We have this circle cut in 2 pieces, and one side is shaded, and it looks like the shaded portion is being rotated clockwise by 1/4 of a turn. So our next picture is going to be straight up and down, but now the left side will be shaded. And then if we turn another 1/4 of a turn, it's going to be at a slant, much like this second picture here. But now the upper portion will be shaded. Okay. And then our last pattern, we have these squares that looks like there's a row being added on each time. So this first one just is 1 square, and then we have a row of 2 squares added on to the right hand side, and then we have a row of 3 squares added on and a row of 4 squares. So for the next picture, I'm going to start by copying the previous picture that had 4 squares going down on the right hand side, and then I'm going to have to add another row with 5 squares. And then for the last figure that I'll draw, again, I'm going to start by just redrawing the previous picture that had a row of 5 squares. And then what I'll do is I'll add a row on the right with 6 squares. So there's our next 2 pictures. All right, so now let's actually talk about what inductive reasoning is. First of all, we need to know what a conjecture is, and a conjecture is just a conclusion based on observations. So maybe when you were little, you noticed that every time it rained, it was cloudy out. So, and you saw that again and again, so you might have made a conjecture that rain comes from clouds. All right, well, inductive reasoning is a process that includes looking for patterns and making conjectures. And you make those conjectures based on the patterns that you see. So as humans, we are really good at this because it helps keep us safe. For example, over time, if you would notice that fire is hot, or touch fire and get burned, you would notice that fire is hot and you would find that pattern and make the conjecture that you shouldn't touch fire. So it does help keep us safe, and that's why as humans we're really good at inductive reasoning. All right, well, we're going to use inductive reasoning to find number patterns. So we'll do examples 4 and 7 first. We're going to do these kind of out of order. And I encourage you to pause the video and give these a shot if you'd like, and then we'll you can go through them with me. So let's go ahead here. In example 4, I noticed that we have 32, 16, 8, 4, and then I can see that these are being cut in half. So if we cut 4 in half, we get 2. If we cut 2 in half, we get 1. So that one's not so bad. Let's go over across to example 7. This one is a little bit trickier. So you actually have to read these numbers backwards. So like if you think of this number here as 81, and this as 64, and 49, and 36. So you have to rearrange the numbers. Now you might be able to see what's going on here. So 81, 64, 49, and 36 are perfect squares. This is 9 squared backwards. This is 8 squared backwards, 7 squared backwards, 6 squared backwards. So 5 squared is 25, and if I write that backwards, that would be 52, the next number in our pattern. Continuing that, we have 4 squared, which is 16, but if I write that backwards, I would have 61 as the last number there. A little bit tricky. Okay, let's go ahead down here to example 5. You probably can do this one without much help. 5, 10, 15, 20, 25, 30. So we're just counting by 5s. Let's go across to example 8. This one is a little bit trickier, but we've got letters here, and I'm just going to count. 1, 2, 3. Think of how those words are spelt. 1, O-N-E, 2, T-W-O, 3, 4. So you see the pattern there, 5, 6, 7, 8, 9, 10 starts with a T, 11 starts with an E. So it's if you would spell out the counting numbers, just the first letter from those. A little bit tricky. All right, both 6 and 9 are 2 patterns in one. So in number 6, it looks like what we've got going on here is they're skipping every other number. So it goes 7, 8, 9, and then if we skip over, we would get 10 right here. And then if we do that with the second number starting with 10, 11, 12, so this last number would be 13. Okay, I think number 9 does the same thing. So I notice every other number is a fraction and the other numbers are integers. So the first fraction is 1 over 2. And then we have 2 over 3, 3 over 4, and then I think we would have 4 over 5. And then these integers, we have 9, 10, 11, 12. And then notice every other is negative, so positive, positive, and then this 12 would be negative. All right, so there's just some practice finding number patterns. And let's look at one last definition here. A counterexample is a specific case that shows a conjecture is false. So if someone makes a conjecture and you come up with something that proves it's not true, that would be a counterexample. And we're going to practice a few counterexamples right here. So we're going to show that the conjecture is false by providing a counterexample. Example 10 says, any four-sided polygon is a square. Any four-sided polygon? Well, what about a rectangle? That's not a square. So a rectangle is not a square. Because a square has to have all 4 sides the same and 4 right angles. A rectangle has 4 right angles, but these 2 sides are longer than these 2 sides, so that is not a square. All right, example 11, every math teacher is uncool. Well, I know that's not true, because Mrs. Scott is cool. Or I suppose you can use another math teacher. If you had another math teacher that was cooler than me, you can use them. I'll forgive you. Okay, example 12, we got a little reading to do here. Juliana, sitting in the last row of a school bus, notices that 6 students in a row get on the bus, all wearing high-top sneakers, and each student sits down on the left side of the bus. She conjectures that every student wearing high-top sneakers who gets on the bus will sit on the left side of the bus. Is there anything wrong with her conjecture? Well, I think so, for many reasons, but the reason that I notice is not everyone wears high tops. In fact, I don't even own a pair of high tops. And if Juliana's conjecture was true, I wouldn't be able to get on the bus. All right, part B. What counterexample will disprove it? Well, what if we've got someone wearing flip-flops? So someone gets on the bus wearing flip-flops, and they sit on the left. So that would show that not everyone that wears high tops sits on the left. Okay? Or you could have someone wearing high tops sit on the right. So there's quite a few ways that Juliana could be proved wrong. All right, our last example for today says that 6 students attend a class party and ate a variety of foods. Something caused them to become ill. John ate pizza, hamburgers, and tacos and became ill. Chi ate hamburgers and tacos but not pizza and became ill. Tasha ate pizza only and felt fine. Ashley didn't eat anything and also felt fine. Andre ate pizza and tacos only and became ill. Joyce ate hamburgers and tacos but stayed away from pizza, and she also got sick. Make a table to organize the information and then determine the food that probably caused the illness. So sometimes in mathematics, we like to organize our information in a table. So in the first column, I'm going to write the 6 names of the people that were at the party. So we've got John, Chi, Tasha, Ashley, Andre, and Joyce. All right, and then in the top row, I'm going to put the foods that were eaten. So there was pizza, they had burgers, and tacos. And then we're going to figure out, did they get sick? So let's see. John ate pizza, hamburgers, and tacos. He ate everything. And did he get sick? Well, yes, he did. So that doesn't really help us because John ate everything, so we can't narrow it down. So let's see. Chi ate hamburgers and tacos and became ill. So it must not have been the pizza. Tasha ate pizza only and felt fine. Okay. Ashley didn't eat anything and didn't get sick, so that doesn't really help us too much. Andre ate pizza and tacos and he got sick. Joyce ate burgers and tacos, stayed away from the pizza, and she also got sick. All right, well, do you notice anything here? I noticed that this column of people who ate tacos lines up with the column of people who got sick. So it appears that the culprit was the tacos. All right, well, that's just a quick lesson here on inductive reasoning, finding patterns, using counterexamples. So your assignment's going to have a lot of inductive reasoning, a lot of problem solving. So I'm glad you guys watched. If you've got any questions, comment below or let me know in class. Thanks again for watching. We'll see you next time.